This is question 9 from the SACE Stage 2 Physics Course Companion from subtopic 3.4, the Standard Model. Here we have beta minus decay, where a neutron decays into a proton, an electron, and an electron antineutrino. The decay is mediated by the W minus boson. So first we have to state the core composition for a neutron and a proton. That's fairly easy. These are things we just need to remember. So here we have the neutron first. So, neutron. Now the way I find this easiest to remember, neutrons have no charge, so they're kind of dud. So DUD, or we write that as UDD for the core composition of a neutron. Proton, we know that has the same quarks but just different numbers of each, and that is just UUD. Not super exciting, but they're just facts that we need to remember. Question B. Here we have to state which force is responsible for beta minus decay and give 2 reasons for our answer. So the first one is the easiest one. We know that the decay is mediated by the W minus boson. That's the gauge boson for the weak nuclear force, so that's our first reason. Let's write that down. So the decay is mediated by the W minus boson, which is the gauge boson for the weak nuclear force. That's our first reason. The second one's a little more complicated. So this interaction isn't a push or pull like a normal sort of force. This is just an interaction that occurs, and it is the weak nuclear force, which is responsible for different types of interactions, not for pushes or pulls like regular forces. So that's going to be our second reason. So to write that down, we'll say the decay is an interaction rather than a push or pull like a regular force. The forces responsible for interactions, for these types of interactions. Types of interactions is the weak nuclear force. So there are 2 reasons why that must be the weak nuclear force. That's not so bad. Question C, we need to write an equation for beta minus decay and show the charge, baryon number, and electronic lepton number are conserved. That's not too bad. We have our neutron is decaying into a proton, an electron, and an electron antineutrino. Let's do charge first. So the left-hand side, neutron has 0 charge, going to the right-hand side, which has +1 for the proton, -1 for the electron, and 0 for the electron antineutrino. So 1 take 1 is 0, and so charge is conserved. Electronic lepton number. The left-hand side, there are no leptons, that's 0. On the right-hand side, we have a proton, so the lepton number is 0. We have an electron, the electron number is 1. And we have an electron antineutrino, which has a lepton number of -1. So we have +1 and -1, which goes to 0. So here, electron lepton number is also conserved. Finally, we have the baryon number. On the left-hand side, the baryon number for a neutron is 1 because it is a baryon. To the right-hand side, where we have a proton, the baryon number of a proton is 1 also. Electron, that is a lepton, so 0. We have an anti-lepton, so that's also 0. That goes to 1, so we have 1 and 1. That is also conserved. These are conservation of charge, a lepton number and baryon number. They're all fairly straightforward questions. If you know what each of the particles are in the interaction, you can't really go wrong. And we know that these have to be conserved. So these sorts of questions should be fairly straightforward. The beta decay you would have seen from the stage 1 course, so it should be kind of familiar anyway. Yeah, this question isn't too bad. It's one of those questions which looks more difficult than it actually is. Yeah, there we are. That's it.